Hey guys, Dario again. This is a video I've wanted to do for a while. A lot of people have questions on the internet about Gen 5, LT1, LT4, and the Gen 3, 4 LS compatibility. I don't really know 100% for sure, but I figured I would try it. I've done a bunch of research, bought a bunch of stuff on eBay, and I'm going to try to throw it all together as a spare engine for my Chevette. My Chevette has a stock bottom end 5.3 in it out of a 2008 Avalanche, and I've always wanted to kind of figure out what would be the next strongest engine made out of all GM parts. So obviously the new LT1 and the LT4 stuff is insane. I think the LT4 is rated at 680-ish flywheel horsepower somewhere. Correct me if I'm wrong, comment below. The rods are just insanely robust. The cranks are a forged twist cranks similar to what was in the LSAs, and still sticking with the Gen 4 platform. In my mind, the 5.3 aluminum block is the strongest out of all of them. It has Siamese bores, really good main webbing, good through-to-through breathing in the block, and they seem like they have super thick liners. So we're gonna just go over here what all the parts I've collected. I'm gonna try to throw it together, put the crank in with all main bearings, assemble one rod with no rings, put that in just to show the TDC and all that. All right, first we'll start with the block. This is a Gen 4 aluminum block. I think it's out of a newer Silverado. My buddy Mitch gave it to me. It was a GM warranty engine with wicked piston slap. So I just cleaned it up, took it to the machine shop, got them to get rid of the aggressive machining marks off the deck of the block, because if you've ever seen a lot of the Gen 4 heads and blocks, they look like they were cut with a hatchet. So I sent it out, got it cleaned, and I already pre-honed it, and then I got them to just do a quick deck on it so it's nice and clean, ready for assembly. And so you can see here what I mean by how thick the liners are. They're just massively thick. Like, I don't know if it's that thickness all the way through, but it's got to be pretty close. And then I also talked about the Siamese bores. If you take an LS block and you take a flashlight, if you stick a flashlight in the bottom hole and you go like this, you'll see light through it if it's not a Siamese bore. But this one obviously is. You can't see light through between the cylinders. That's what Siamese bore means. It means that these two cylinders, the aluminum between them is touching, or one piece. Whereas iron motors and the earlier L33, 5.3s and stuff, they have a gap there. So that combined with probably 1/4-inch wall liners, this has got to be the best based boost block to build off of. So if you didn't know about that, that's what I wanted to just show with that. This has had the DOD in it, but you can just use the different cover to block it off. And obviously Gen 4, no rear cam sensor. The cam sensor goes in the timing cover. So there's that. So I'll show you the differences in cranks right now. So here's a comparison of the crankshafts. So this one is a dry sump crank. You can see how the snout is really long. I'm guessing it's out of a newer Corvette, like LT1, maybe LT4 Corvette. I have no part numbers or anything on it. It was one that I bought off of another guy that worked at a machine shop, and he said it was an LT1 crank, but I'll show you the differences in a minute. It is a forged crank. It is a twist forged crank. It's got the parting line there. This is one I got on eBay. Paid $75 for it in an auction plus some shipping. This is out of a 2017 LT1 Camaro. So all the Camaros are wet sump. So you can see the crank is shorter. The keyway's up here. That's the main difference with the LTs, is all their balances are keyed now. They're not like the LSs where they don't have a keyway. So this is an LS3 crank I had kicking around just to show you the differences. other than this is obviously a cast crank. It's just got the thin parting line. That's how you tell the difference if you didn't know. This is a twist. All these LT cranks are twist forged, so they're the same as an LSA crank. So what they do is they cast the crank with all the journals in line, and then they actually heat them up and turn them. So you can see the casting lines here, the casting lines here, the casting lines here. So they just twist this thing. If you look it up on Google, it's called a twist forging. So it's not as strong as an actual forged crank, but it also can't be worse than a cast crank. Just the quality control has to be a lot higher to do something like that. So I assume that that's what makes them better. They're still undercut, if you know what that means. Like older small block Chevys and aftermarket LS cranks have a radiused fillet, whereas these cranks have a undercut fillet, just like an LS crank. There's just like a little groove cut into it to undo stress, I guess they use it for. So that is the main difference. The LT cranks are the same as the LSA cranks. They have the flywheel mounting pattern is an 8-bolt. So companies, like if you want to use a flex plate to work on your Turbo 400 or whatever you got behind your engine that you're building that has an 8-bolt crank, TCI makes a flex plate for them because the Copo Camaros have the 8-bolt crank, and you could use a stock LSA flex plate, or I guess a stock LT flex plate if you wanted to go that route also. I've only ever used, on the one engine I built for a customer that had an LSA crank in it with the 8-bolt, we just bought a TCI flex plate. It wasn't cheap, but we didn't really have any options if you're trying to get something that's SFI approved. So yeah, the main difference is this is a wet sump or a dry sump crank. This is a wet sump crank, and then this is a stock LS3 crank. So visually, other than these being forgings, they look pretty close to physically the same. The weighting is a little bit different. These have through holes on the crank here, here, here. You can see them where these are dead holes. They don't go all the way through, and then they don't have them on the other ones. It's a little bit heavier of a crank. This is an LS3 crank out of a truck, so I don't know if the LS3 cranks out of a car have that. And then I'll show you the difference here. This is the same even on if you're doing a wet sump conversion on a LS7 or an LS9. You can see all I got is a file, so you're gonna have to kind of wing it here with me. Excuse the mess. This is my home garage and I got shit everywhere. So you can see that's the end of the crank. There's the end of the crank here. It's about 900 thou, I think, from what I've looked up. They do make spacers for that, but the only other problem with these LSA, I'm going to call them Camaro LT1 cranks, it has to be, from what I've learned, I'm not going to tell you to go get a Corvette one because I'm pretty sure it's going to all end up being like this. I don't know enough knowledge if all the LT1 Corvettes are dry sump or wet sump or have a different accessory so they don't have to change it up between the two. So the main problem is if you look at this crank, it's got a really short keyway. The keyway only comes to there. And then there's nothing all the way to the end. On the wet sump crank, the keyway comes to here and then there's a little space. And then obviously on a LS3 crank, the keyway starts here and goes down to here. So that's what holds the gear on. The problem with this is if you need to run an aftermarket timing set, it will not work. Because if you've ever installed an aftermarket timing set, you know it has the little gear that goes on, and then it has the piece that slides over that drives the oil pump. Well, that part will be fine. It'll drive the oil pump, but then the timing set will only be held on by press, like by the tightness of your balancer. And if something slips, chaos will ensue. So like, even when I do LS, the last one where I did LSA stuff, I had to use a stock style timing set. So I used stock upper gear, lower gear, and a C5R chain, or you could use an LS2 chain, or you could use a stock truck chain. It doesn't really that part doesn't really matter. But the main thing that matters is you have to use this gear, like the one-piece gear with the oil pump drive that grabs the keyway. That's the number one thing. The problem with these LT, I'm just gonna call it an LT crank because I don't know if it's LT1, LT4. It's an LT and it's a dry sump crank, is the keyway stops there. If you look at the gear, it's nowhere near it. So even if you use this, it's not gonna grab the keyway and spin the crank. So this would just press on and spin freely. So I'm guessing the dry sump cranks have a lower gear that sits against here that goes all the way out to whatever point the balancer goes on. So it's got to be like somewhere way out here. But that won't work with a stock style LS timing cover. So your only options with this is getting another keyway cut. You could also get another keyway cut on this one. And then this one, you probably have to chop it off and shorten it to the dry sump length, which kind of neglects unless you know somebody who can cut a keyway for you, that's going to kind of negligate using this crankshaft. This crankshaft, I don't even know what I'm going to do with it. It'll probably just hang out unless I find somebody that needs one for a wet sump or a dry sump deal. So that's the main part of the crankshafts. They're all 58X. They all use the same reluctor. They all even, like, you can see this is the balancing holes on the LT wet sump crank, the Camaro crank, and this is on the truck crank. You can see that it's almost got balancing holes in the same spot. I would still get everything balanced, obviously, especially when you're mixing rods, pistons, and etc. So the next thing I'll show you is the rotating assembly, or the piston and rods. All right, here we got a shot of an LT4. This is the supercharged LT engines that come in the Corvettes. Like I was saying before, they make about, I think, around 680 flywheel horsepower. Next to a Gen 4 rod. They're pretty close, but I can put the Gen 4 rod on top of it. And you can see GM was on the ball with these. They added they added to the beam, they added to everywhere where it counts, they added a extra weight to it. But then these are also an I-beam style rod, like that, and then it has this is like a strut to support the pin, so you can run a lighter weight pin and this will kind of support the edge of it. It'll probably still flex, it's not invincible, but there's that. They use these are the factory bearings that came with these rods. I got these rods on eBay probably like a year and a half ago. I've been kind of stewing about this project for a long time. They're like a red coated bearing. They're not like a standard small block Chev bearing like the LS's use. Apparently the tangs are in a different spot, so you can't just drop a LS or a small block Chev standard King or a Cleveite bearing into these things. Apparently guys are grinding the tabs off and just putting them together. These bearings are in excellent shape. I'm just going to run them. These are like some sort of factory takeout. There was a dude on eBay slinging them. I think I paid $180 for them with some kind of discount. But they're super robust, right? So everywhere they need to have extra stuff, they have it. And they actually, as crazy as these rods look, I think they're within 1 or 2 grams of a stock Gen 4 LS rod. This is a Gen 4 LS rod. I think it's bent. Can't really tell. Doesn't really look bent, but I think it is. Anyways, so yeah, that's the rod. Here's a rod and piston. So this piston, I also got them on eBay. These are factory takeout. 5.3, I'm going to say one of the last year's 11, 12, 13, still a Gen 4 rod with when it had VVT with the VVT relief pistons. These are like $100 with rings and pins, but no locks on eBay. They got the coated skirts. They're a little bit sharp on the edges here. I usually hit them with a little bit of Scotch-Brite just to knock the sharp edges off, because that usually turns into hot spots. The reason why I use these pistons is because the underside of the piston is wider. This section is wider. I have they call this a cross-top L33 piston. As you can see, this spot here is wider than this spot. That matters when you're putting the rod together, because as you notice, the top end of this rod is that wide, and Gen 4 rod is this wide. So this rod will fit into here no problem and have enough side clearance to move back and forth. Well, this rod won't. It's pretty tight. Like, it just about touches. It maybe has 50 thou clearance. But on this piston, this rod has insane amounts because of the way it's tapered. This pin bore, not the pin bore, but where the rod rides is tapered, and this one is straight. It goes straight up and down. So one's tapered, one's straight. So that makes it up when you put the tapered rod into the hole where the stock piston is. And you see, you got, this thing probably has a little under 100 thou a side. So no modifications necessary. If you couldn't do that, say you couldn't use these pistons, you were using them on something weird, like I don't even know, like some kind of piston, say you got a dish 6-liter piston and you really want to use it because you want low compression, you'd have to get these side clearance. So they put them in a mill and they clearance or grind the sides of these off thinner, which wouldn't hurt anything, but might as well use them as is to save the most amount of money. So there's that part. So here's the put together assembly. A lot of the time online, the big misconception is I don't know if GM was trying to steer people in the wrong direction because they didn't want this to be figured out. But these rods were, if you look them up even on GM's actual site, they say the LT4 comes with a 6.125 rod. Well, it doesn't. It's a 6.098 rod, just like a Gen 4 motor. Once that was figured out, then it was kind of game on. So you can see right there, it's lined up. And one of these doesn't have a bearing, but you can kind of see the bore is the same. It's definitely not 25 thou out. Like right there, right there. It's like perfect circle. So they're actually 6.098. I haven't checked the new LT1 rods. I was going to order a set of those, but I'm assuming they're the same thing. Like GM says they're 6.125, but they're actually 6.098. But the problem with those rods is the same problem that you can have with the LSA rods if you put them in a regular engine without one of these cranks, is the top of this gusset will actually hit the crank counterweight. So there's like definitely mock-up needed to make sure that this edge has enough clearance over on a LS rod versus an LT rod. So that is the other thing with this. So what I'm going to do is I'm going to put the crank in with a full set of mains. I'm not going to check the clearances for now. I'm just going to get the crank, the Camaro wet sump LT1 crank. I'm going to put it in the 5.3 block, and then I'm going to show you that. I'll spin it, and then we're going to put this rod and piston in it with no rings and check the deck height and see how high it pokes out, and that'll kind of verify everything that's been going on the internet up until now. You can still buy, of course, because they're still current, you can buy these rods from GM. So like they're still probably comparable or less to Manly or any of the Chinese offshore rods. So I have no doubt, like with what everybody out there is doing now with stock Gen 4 stuff, with how stout this rod is, I could see no problem that this could be a 1500 horsepower stock bottom end made out of stock GM parts, as long as you can keep the heads down. So we got the crank in. I just threw it in with some just off the shelf standard LS bearings, just some SI Kings, just the basic Kings. Like I said, I haven't checked the clearances yet. I just want to kind of get this mocked up. So if it does work, I'm going to send it all out to get balanced, and then that'll be the next hurdle. But here you can see it. It's in. You can see the 8-bolt crank. It still has the pilot bushing because this is actually a used crank. It was out of a takeout engine that I'm guessing they did a stroker on. Crank trigger clears. You can see it down there. Clears the stock gray 58X sensor. So I'm assuming it would, if you put a 24X on this, it would also work. But yeah, so I put it in. I just lightly tightened down the mains, set the thrust. So I don't know if you can hear that, but it's got about 6 thou, 7 thou end play. And yeah, it spins just like nothing. It's not hitting anything. No weirdness. Like always on the LSs, it's really tight in here between the front main. So when you wipe out your thrust, that's what turns into the thrust. You think I'm kidding, but no. But yeah, like you can see in the back there that the LTs actually have a hole that goes all the way through, and then they have a cup plug to plug the hole to the back of the crank, which is kind of cool, but kind of different too. It has a hole through every single main. I never really noticed it before, but that should make the crank a little bit more lightweight. And show you there, show you there. Since forgings like to wobble around a bit, the last one I did with the LSA crank, I set the clearances on the loose side, but also if you're going to be turning this thing up and maybe you're going to run it on methanol because you don't want to push water out the heads because you only still have the 4 bolts per cylinder, you're probably going to want to set it to the loose side of the clearances anyways, even though it's an aluminum block and the clearances will loosen up a bit. So the next thing I'm going to do is I'm going to put the rod in on number 1 and we'll see what happens. One quick thing I'll show you about what I was talking about, the locating tabs being different. You can see right here, see how the locating tab is way out to the edge on both sides. So like they've changed that up about the bearing, maybe to make it not work the same as a LS, or so GM can say they actually designed something different over the LS or whatever. So this is the LT4 rod, and just for comparison, there's the standard LS small block Chev style rod. So you can obviously see why it wouldn't work, because if you tried to put a bearing from an LS in this tab, this one, the bearing would be about this far out one side, depending, yeah, because the tab would be on this side. So it would be way out on this side and it wouldn't work. So apparently there's that one guy, the dude with the crazy fast Chev truck in Kuwait, and he was asking about it, and guys were saying that if you need to run an LS bearing in an LT to get the clearances right, you just grind that little tab off and just hope the crush of the bearing holds it into place. I'm not sure. I don't build a ton of engines to know that that's acceptable. I would probably just go buy new bearings from GM and hopefully get the clearances on the first try. If not, you're gonna have to roll with it. But I'm guessing these coated bearings from GM are gonna have a pretty loose clearance, since this engine makes 680 flywheel horsepower. I know the LSAs come factory with a little looser clearances than say an NA engine that makes 300 horsepower. So we'll have to see. Just a quick tidbit. Back to installing the rod and piston. So there we go. The suspicions were right. It's perfect. Engine's at TDC and it's flush. Like all the LSs, you'll always be able to kind of feel the edge of it. I don't think they took much of the surface of the deck off to clean this off, obviously, because you can still see the pitting on the edge. They just did a quick smoothing. So yeah, it's at TDC and each way rocks down. So It is absolutely flush. It's not 25 thou, or I guess it would be 27 thou sticking out if it was a 6.125 rod. So you can see it there. You can see what I mean by the edge of the piston kind of goes down in the bore. So I always smooth these edges out because what'll get nipped if you get some crazy leanness per cylinder. But yeah, goes all the way down, goes all the way back up here. I'm gonna flip it over here. So here we go. Goes around. Rod bolts clear the edge of the cylinder. Everything clears with a mile of clearance. So there we go. You can see the rod feels loose. So I haven't checked the clearance, but I'm guessing it's probably pretty loose. Definitely probably over 2 thou just by the way things are moving around. So yeah, there's that. This is something that people have been asking about, and I'm sure I'll get a cease and desist from GM for letting the secrets out that the new LTs aren't that much different bottom end wise from a LS. They're just definitely way better. Like strength wise, they took something like the Gen 4 LS with the good LS2 style rods, and they made it even better. So the LT1 rods I'm going to say are comparable to the LSAs. I am probably going to pick up a set before I post this video because I probably won't be able to pick up a set of anything after. And I'll probably do a mock-up on another engine with that. And then now that I have this all together, I'm going to probably send all this stuff off to get balanced and see how that works out. The piston, I'm guessing if you've ever seen the 6.2 direct injected pistons, they look like a pretty solid piece. So I'm guessing they're going to be way heavier than a 5.3 piston and this rod that weighs about the same as an LSA. So or as a Gen 4 rod. So I'm hoping it'll all balance out. That's something I'm going to have to talk to my machine shop about. But yeah, like if you want, honestly, the stoutest probably Gen 4 bottom end on the planet with a mix of Gen 5 parts, this is it. Like if you want to keep your GM all GM and not put a offshore Chinese crank in it or some Chinese rods or whatever, this is how you're going to do it. This one, I know I'm going to, if I ever called it a stock bottom end, I'd have a never-ending emails of hate mail telling me that it's not a stock bottom end. But I'm going to call this is a GM bottom end made out of all GM parts. I'm going to use a GM timing set on it with the C5R, which is a GM chain, GM oil pump, GM rings. The only thing that this thing probably won't have is GM main bearings because I'm a little bit particular about my bearing clearances, so I'm going to want to put them where they should be. But obviously, guys with the cast crank 5.3s and 4.8s that are going crazy fast, they're just using what GM gave them. So if this thing, like, honestly, like, if I ever kick the rods out of the motor in the Chevette, actually the Chevette's up there. I actually never posted a picture. It's just hanging out for the winter time. Well, it's actually been hanging out there for the last few months, but this will be the next engine. This with a set of as cast Trickflow 220s welded onto the top of it, or some 1/2-inch head stud conversion. I'm not totally sure. I was actually thinking about doing the 1/2-inch, getting this block sent out and doing the 1/2-inch Cleveland head studs. That's another thing if you don't know. The 1/2-inch Ford Cleveland head studs are the same length approximately as a LS head stud. So if you can get your block tapped out from the 11 mil to the 1/2-inch, you can use Cleveland head studs, which don't have LS tacks on them. So they're like $135 a set. And just by going up from the 7/16 or 11 mil diameter up to the 1/2-inch gives you so much more clamping force that you don't have to go to the crazy H studs or the L19s or whatever with them. You can just use the cheapest set of Cleveland head studs, and they'll do just as good as those other ones, except you got to pay to have the block tapped. So I thought I'd just clear that up for everybody. I'm learning too. I love learning about this kind of stuff. So if you like what you saw, share it. I'm sure this will take off pretty big and people will be trying to access this stuff. This is just something I wanted to do. I thought it was really cool. I've never even had my hands on a LT type engine yet, like the 5.3 6.2 or the LT4, which is a 6.2 also. But yeah, so that's that. And I'll probably do another video on this thing once I get it all back together and assembled. But like I said, I'm thinking about doing the 1/2 inch head stud conversion. And because when I'm at the point where I'm going to kick the rods out of the motor in my Chevette, I'm hoping I'm at a seriously decent power level. Thanks for watching.